By the end of this lesson, you will be able to identify the different sampling techniques, identify if your sample is biased or unbiased, and you'll also be able to tell the difference between the sample, a population, a sample statistic, and a parameter. All right, so all this lesson is just applying definitions. So if you have two things. You have what's called a sample and a population. So if you're going to do a survey, or you're going to collect some data. Let's say I want to collect data about high school students in York County. So my whole population is all the high school students in York County. And I don't want to interview or ask questions from everybody, so I'll take a sample of that. So maybe I'll pick a few students from each school, or I'll talk to just one high school, or there's different ways of sampling what's called your population. So instead of asking everybody in a group, I ask part of a group. Everybody's your population. The sample is the group that you select to talk about. Your samples can be unbiased, meaning it's going to be representative of the larger populations. There's going to be no preference. I'm not going to, so for instance, if I was like, hey, I'm going to ask students how they like their math teacher in York County, and I only ask Miss Collier students, obviously that's going to be biased. All right, I want to ask all across the board. So I want students from each math teacher. So biased is when it's not representative of the larger population. Okay, so it's really biased. I ask only a specific amount of people, or I ask the question in a way where I only get information from certain people. So there are three types of unbiased samples. Actually, there's more than that, but we're going to talk about three types of unbiased samples. The first one is a simple random sample. So a sample where each item or person in population is as likely to be chosen as any other. So let's say I do want to interview all the high schools, or I want to get data from the high school students in York County. What I could do is ask the guidance counselors to just pick some random students from each school and then give me those students' names. Okay, so it's just a random sample. I could do what's called a stratified random sample, a sample in which the population is divided into similar, non-overlapping groups. A simple random sample is then chosen from each group. So let's say, hey, can you give me some freshmen? Can you give me an equal amount of sophomores, an equal amount of juniors, and an equal amount of seniors? So then I would pick random people out of freshmen, sophomores, juniors, and seniors. Okay? Instead of just doing a random high school students, we're going to say, hey, they could be in any grade. I'm just going to pick random high school students. Let's say I put every high school student name in a box and I just pull out random students. Or I could put all the freshmen in one box, pick out randomly from there. All right? Pick out some random, put all the sophomores in a box, pick out some random from there. Out of the junior box, pick out some random, and out of the senior box, pick out some random. So if I just put a box of all high school students and pick out random numbers, that's a simple random. But if I do it freshman, sophomore, junior, senior, then that's called a stratified random sample. There's also a systematic random sample. It's a sample in which items or people are selected according to a specific time or item interval. So I say, all right, give me the list of every high school student in your county, and then every 10th student I'm going to choose. That's a systematic random sample. So I just go from the list and I go 1, 2, 3, 4, 5, 6, or I guess I'm picking every 6. 1, 2, 3, 4, 5, 6, pick that student. 1, 2, 3, 4, 5, 6, pick that student. Again, it's random. So these three are all random. All I'm doing is picking random people, and so that makes it unbiased. Okay, so that makes it an unbiased sample. And I could do it as a whole. I can put them into groups and then do random, or I could just go every 10th student, every 6th student, and every 15th student. Okay, so all those are considered unbiased because they're completely random. There's two types of biased samples we're going to talk about. One is called a convenience sample, a sample that includes members of a population that are easily accessed. So for instance, if I want to talk to York County School high school students, but I only talk to York River Academy students because they're the ones that are close to me. I'm not going to get a good representation of all high school students in York County. I'll only get a representation of York River Academy students. But those are the students I'm closest to. It's easy for me. I don't have to worry about it. Voluntary response sample. It's a sample which involves only those who want to or can participate in the sampling. So let's then say I send out a survey to all high school students. All right, just say, you know what, I'm just going to send a survey to all high school students, and then I'll just use the ones who send it back. All right, that is biased because let's say I ask the question, what do you think about your high school? Okay, do you like your high school? List the things you don't like about your high school. Maybe those students who are really upset about their high school will be more likely to turn theirs in. So then we're not getting a random sample. We're only getting the sample from people who would want to respond. Okay, so I won't be getting all the data from all the students across the board, only those who would respond to it. So that's a voluntary response sample. And again, that's considered biased because I'm getting a collection of students who want to respond. So what we're going to do is we're going to look at these 4 scenarios. We're going to decide, is it biased or unbiased? And then we're going to describe its type. So its type is either simple random, stratified random, systematic random, convenience, or voluntary response. So let's look at example 1. So to determine the average number of hours that a student's Let me read that again. To determine the average number of hours that students study, members of the math club are polled. Identify the sample as biased or unbiased and then describe its type. So I want to know the number of hours students study, but I'm only going to ask the math club. Now, no offense to people in math club. I was in math club. But these tend to be students who are a little more studious, who enjoy math, who are more likely to do math homework. All right, and again, let's say I'm in the math club, I'm only asking those students. So this is a biased sample. And if we look at our types of biased ones, it's a sample that includes members of the population that are easy access. So I asked just the math club. Okay, so this is a convenience sample. All right, so I just asked members of one club. Okay, it's not random, and then it was just convenient just to ask the students from the one club. So that's a convenience sample. All right, example 2. A television studio wants to know what viewers think about their programming. They mail a questionnaire to a random selection of residents in their area. Identify the sample as biased or unbiased and describe the type. So, even though they send a questionnaire to random selections of of residents in their area, when they get responses back, it's not going to be as random. So it's not going to be as random as you would like it to be. So even though I sent out a random survey, the people that are going to respond are just the people who can or are willing to respond. So even though it started out probably being a little unbiased, your results will be biased. Okay? And then the reason why it's biased, because it's a voluntary response. Okay, so fill this, we would like to hear from you. It's a voluntary response sample. Again, you're more likely to hear people who want to respond. A lot of people get that and be like, I'm not going to deal with this. All right, so you're not going to get a good representation of your population as a whole. So whenever you send out a survey and then you just wait for people to return, that's not considered an unbiased sample. A new bill is being passed in the state Senate, but politicians want to know what their constituencies think. One politician decides to go to every 10th person's house in a neighborhood and ask how they feel about the bill. Identify the sample as biased or unbiased and describe. So we have a person, let's say they have the list of their constituents and they're going to go to every 10th person on there. Like, okay, I'm going to go this house, 1, 2, 3, 4, 5, 6, 7, 8, 10, this house. All right, so it is random. All right, it is going to be a random sample. And if you notice, it's that systematic random. So this is an unbiased sample because I'm not picking it based on anything but numbers. And since I'm picking like every 10th, it's a systematic random sample. All right, so that is unbiased. To test the frog population for diseases, an environmental group examines 50 males and 50 females. Identify the sample as biased or unbiased and describe its type. So they have, to test the whole population, they're just going to find 50 males and they're going to find 50 random females. All right, so since they're saying, okay, I'm random 50 males here, random 50 females here, it is a random sample, so it's unbiased, but they did it into categories. So they didn't just say 50 random frogs, they said, all right, let's do 50 random males and 50 random females. So this is a stratified. Oh my Lanta. Stratified random sample. If they just said, hey, I'm just going to pick 100 random frogs, that'll be a simple random. But they split it up into 2 groups. Again, this is unbiased. All right, so if you make your sample random, then you're being unbiased. If your sample isn't random because either you just picked a group that was just right there, easily accessed, or you just pick the people who want or can participate in a sampling, then that's a voluntary and that is biased. All right, the other definitions I want to talk about was what's a statistic and what's a parameter. So statistic is a quantity calculated from a sample. So let's say we're talking about those, on a scale of 1 to 10, how do you like high school? Okay, and I randomly select my students for that, and I get an average of 9 for that random set. That'd be really nice. Let's say an average of 5 for that random set. Then that is a statistic because it's for that random set. What a parameter is a characteristic of the population as a whole. So if I did ask every high school student and I got all that information from every high school back, then that's a parameter because it's a characteristic of the population as a whole. All right, so the statistics can change. If I grab these 100 students randomly, but then the next time I grab another 100 students randomly, like the statistic can change, but the parameters do not because it's for the whole population. So that's if I ask the whole population. All right, so we're going to do for these next 2 scenarios, we're going to identify the sample, we're going to identify the population, then we're going to say what is the statistic and what is the parameter. Okay, so a meteorologist places 10 weather stations in a county to measure rainfall. The median annual rainfall is collected for the sample. All right, so we're going to say what is the sample? That's weird. What is the sample? And what is the population? I don't know what I'm trying to spell there. Population. All right, so the sample that he did, he's probably calculating he wants to know the whole county, so that's your population. So the population is the whole county, but his sample is those 10 weather stations. Okay, so those 10 weather stations are the sample. So he's not collecting all the data for every inch of the county, but he probably takes 10 and puts them around, and that'll be good data collection for the county. The statistic, they're racing Power Wheels out there. The statistic, all right, would be the median annual rainfall of the stations. Okay, so of just the stations, so that's the statistic. So it's the data from the sample. The parameter would be the data from the whole county. So it's the median annual rainfall of the entire county. All right, so let's go over that again. So my population is the entire county. The meteorologist says I want to sample 10 weather stations. So the statistic is when he goes and calculates the median rainfall of each station. The parameter would be the median annual rainfall of the entire county. And our goal is to always make the statistic a good representation of the parameter. So that's always our goal of statistics. Like even though it might just be those 10, and it's not exactly what the parameter would be, it would be a good sample so that our statistic will be close to our parameter as possible. A scientist randomly selects 20 trees in the forest. The mean height of 20 trees is then collected. All right, so we're going to do our sample and our population. All right, so the sample is the 20 trees, okay? The population is the whole forest, or all trees in the forest. Let's put that, because it wouldn't be like the grass in the forest. All the trees in the forest. So even though he wants to know data for all the trees in the forest, he's just going to collect data on 20 random trees. So our statistic would be the mean height of the 20 trees, the 20 trees, and we're going to apply that to say, hey, the parameter that he's looking for, even though he's just getting the statistic, is the mean height of the entire forest of all the trees in the forest. All right, so the sample is, the population is the whole, everybody you really want to know information on, but we're only going to do a sample on that, so a random group from that population. The statistic is the information we get for the random group. The parameter is what would be the mean height of all the trees, or all the entire population. And our goal is to get our statistic as close to the parameter as possible when we do like a survey or do samples. All right, so you're going to do the next sheet. It's 1 through 5, and then it looks like 1 through 3. So that's not too bad. It's only 8 questions.